Question 18. A box contains 4 yellow cards and 6 red cards. 3 cards are chosen at random, one at a time, without replacement. Part A. Calculate the probability that the first 2 cards are yellow and the third card is red. You must show all your working. So I've started off a factor tree here. You don't need to do the whole factor tree. In fact, you probably don't need to do a factor tree at all, but I like just to visualize sort of what's going on. And as always, this is sort of the first dip into the bag, and this is the second, and then this would be the third dip into the bag to select the cards from random. And because we're told the first 2 cards are yellow and the third card is red, we don't need to do a full factor tree, because we can kind of go, right, we're going down these limbs of the tree, we're going yellow, yellow, red. Okay, so the start of the tree then, we have 10 cards in total, regardless of colour, and the probability that we pick a yellow card out of those 10 will be 4 out of 10. And the probability that we pick a red card will be 6 out of 10. We're not interested whether we get a red card, because we've been told that the first 2 cards are yellow. Okay, so we've now, at this point, we've picked our first card, it was yellow, and we're about to pick our second. So the number of cards, regardless of colour, in the bag are 9. Because we had 10, we've taken 1 out. How many yellow cards remain? Well, we've already taken 1 out, so there were 4, there are now 3. So that's our second dip into the bag. The third dip into the bag, there are now a total of 8 cards, regardless of colour, because whatever's happened previously, we've taken 2 cards out of the bag. So out of our total of 10 that we started with, we've only got 8. And now we want to know how many sort of reds are still in the bag. Well, we've not picked any reds at this point, so we've still got all of them to potentially grab. So there are 6 out of those 8 to grab. The probability of all this happening then, as always, we multiply down the limbs of the factor tree and we add across if we want to work out different probabilities for different questions. But in this case, all we want to do is calculate the probability that the first 2 cards are yellow. So that's 4/10, probability of the first card being yellow, times by 3/9, that was the probability of the second card being yellow, and the probability of the third card being a red, 6/8. So we need to multiply all those together. Multiplying fractions is nice and easy, because you just multiply the tops and multiply the bottoms together. So 6 times 3 is 18, times by 4, 18, 36, 72, and what's the easiest way of doing this? 90 times 8, or 8 times 9 is 72, times 10 is 720. So that is just 1/10. 72 cancels top and bottom. So that's question 18, part A. So part B of this question, calculate the probability that at least 1 yellow card is chosen. So I've already drawn out the probability tree here. It makes it a little bit easier for me just to visualize what's going on. And when there's a lot of room in the exam, sometimes it might be easier for you too as well. If you've got the space there, you might as well use it. So the probability that at least 1 yellow card is chosen. So all we need is 1 yellow card out of the 3 times that we stick our hand into the bag and choose a card. So we could get that by going this way down the tree. We've chosen, or this whole side of the probability tree, we start off with a yellow, so every single sort of outcome we have at least 1 yellow. So we could do that. Red, yellow, yellow, so we've got at least 1 there. Red, yellow, red, we have at least 1 there. And basically, as long as we don't end up picking 3 reds, we have got at least 1 yellow. So that can be sort of expressed mathematically as 1 minus the probability that we pick a red card, or all reds rather. So the probability that we pick all reds is this root here, multiplied together. So the probability that we get 1 red is 6 out of 10, because we're told right at the beginning 6 red cards, we have 4 yellows, so 6 reds out of a total of 10 cards. If we pick a second red, well, there's only 5 reds in there now because we've already taken 1 out, and there's only 9 cards total in there regardless of colour, because we've already taken 1 out that just so happens to be a red. And if we get yet another red after that, there's only 4 reds left in there now because we've taken 2 out, and there's only a total of 8 cards in there regardless of colour, because we've taken 2 cards out that just so happen to be red. So the probability of getting all reds, or the probability of sort of getting no yellows, is these times together. So 6/10 times by 5/9 times by 4/8. So 5 times 4 is 20, times by 6 is 120. 9 times 8 is 72, times 10 is 720. The zeros can cancel there, so we have 12 divided by 72. 5 times 12 is 60, so 6 times 12 is 72, so 1/6. So that was the probability of all reds, is of picking all reds is 1/6. So 1 minus 1/6 is actually 5/6, and that's the probability that we get at least 1 yellow card when we stick our hand in 3 times. So I hope that helps. A few things to take away from the question, I think, are to not be afraid, sometimes draw this out in the exam. Certainly for me, I don't necessarily find probability particularly straightforward. It can sometimes be a little bit counterintuitive, especially as you go on to study more advanced maths. So sort of having a visualization can certainly help. And also trying to think about it in sort of a different way, because you might be tempted to go, right, let's work out probability of 3 yellows, probability of 2 yellows, 1 red, probability of yellow, red, yellow, yellow, red, red, and then adding them all together. But that is surely far too long. And sometimes just taking the probability of 100 or 100%, take away the probability of something not happening, is sometimes a bit easier. So yeah, I hope that's helped. That's question 18. If it has, please leave a like, comment, subscribe. That will really help me out. Yeah, thanks for watching.